All right, we are now recording and welcome. This is what session now? 4 or 5?
Session 5, I think, because we're on
I
chapter
think.
5.
Yep.
Okay. And
Well, session 4,
I think
right?
it's
Because we do 1 and 2 at the
yeah,
same. Oh no, it is
yeah.
5 because we do
Oop, never mind then.
chapter 3 is 2 sessions.
it sure was. And
Yeah.
I don't know if anyone has recovered from it yet. Hopefully, this no, what I'm going to do is going to be a little easier to swallow and go through and try to make it a little lively. And okay, first thing is, are there any questions from the previous session? Is we had some really good stuff about that. I've got a little demo of some various antennas and things of that sort, and some suggestions about rigs and things. As a matter of fact, I just got myself an new antenna. It's probably one of the least efficient antennas that I've ever bought, but I'm going to use it in the car for parks on the air type thing. So yeah, I'll just stick it on the ground, either a spike or a tripod, and operate from the car at low power. So we'll go from there. All right. All right. Any questions now for any of the previous sessions? Something that's been bugging you, or I just can't get those Smith charts. No one knows what a Smith chart is anyway.
Yeah.
Okay. Well, let's see. All right. I'm going to was trying. I had lunch with one of my friends, and I had to tell him, don't worry about SWRs." Uh, Bob, did you talk about SWRs at all?
Yes, we did. Yeah, we
Okay,
did.
and
But of
everybody,
course, for technician class, it was it was the 1 mile wide and 1 inch deep. So
yeah, but everybody talks about the SWR. You have to have a 1-to-1 or else nothing is any good, and it doesn't work that way. It just doesn't. So we can live with higher SWRs. I'll talk about that a little later on. Okay. Equipment modulation. All right. Let's uh, hang on a second. I'm going to open up a couple of windows in my computer, and then I'll start sharing with you.
Kim, did you check your email? I finally sent you the the slides.
Yeah, I got it.
Okay.
Thank you.
Yeah, we were harassing Bob a few minutes ago on that. That he
Okay.
sent it so late.
All right. And where's my chapter 5? HPARC. Okay. There's one more thing to open up. Switch. Okay. All right, we're going to talk about several things. We're going to talk about doing something with the signal that we're putting out in the antenna to make it meaningful, because just because you have a signal out there doesn't mean that someone is going to receive it and know what you're talking about. You have to put some kind of intelligence on it. And then we're going to talk about different kinds of equipment that are available, and I'll throw in a few things about installing stuff. All right, let's share. Where am I? Share. Okay. All right, screen sharing.
We see your screen.
Okay. All right, this is a typical 1950s ham radio station, a beginner's type of thing. This is the receiver, which is an old National. You see it has two dials on it. One was the general coverage dial, and then the band spread was kind of vernier. You could, well, it spread the band open for you, so you can use the whole dial to take care of a band. And you had a separate transmitter. This one was I guess a little more advanced Heathkit. Heathkit back in the day was a wonderful company. They sold kits, which you would put together yourself. They'd sell you, well, they had the chassis, everything all silk screened on it. And you'd got packets of resistors and tubes and not too many transistors at this point of time, but full instructions, and you really had a sense of accomplishment. This is the a little up the line, because this did both CW or Morse code and phone, AM phone on it. So the thing came with a crystal control, which means that you didn't have a dial to match what you heard. Today the transceivers are set up so both the transmitter and receiver are on the same frequency. With this, you would transmit on one frequency, then you tune around to see if anyone heard you, and you'd tune up and down maybe 15 kilohertz. Okay. And one of the other problems with this kind of setup is that the transmitter and receiver were two separate units. They shared the antenna. And what you had to do, just like Dr. Frankenstein did, you had a switch. So this center part would be connected to the antenna, and you could switch to the transmitter to transmit. When you're finished, you would switch over to the receiver so the receiver could pick it up. And if you made a mistake, then the transmitter is going to transmit into an empty switch, and would be very, very unhappy. Okay. All right. All right. This is a joke. It's a wonderful transceiver, but somebody photoshopped the ultimate contesting station on top of it, which has a built-in coffee maker, microwave, and refrigerator. So if you're in a contest, you don't have to stir from your seat, and you can feed yourself, keep yourself awake, and so on and so forth. doesn't exist, but anyway, it's a nice idea. And
Anybody who's ever done field day wants two of these.
exactly. And of course, I think this is the $12,000 radio. I liked one of those too, but I can't justify the expense. Okay, here's where we're going. We're going to talk about the signals that we're putting out into the air. Now, we were talking before about circuits that made electrons flow in very complex ways, and they didn't do anything until they hit the antenna and became an electromagnetic wave. Then the electromagnetic wave would hit another antenna, which would turn it back into a complex movement of electrons, which would be received in a way that you could possibly pick up some intelligence. Now, what you're sending, if you're not putting any information on, is just a radio signal, a radio frequency signal, and it's not doing anything. If you have a receiver now, you can tune, and there are plenty of places around where you'll hear just what's called a carrier wave. It's just goes on and on and on. It's a simple tone, and it's not telling you anything. But you can make it talk by turning it on and off. So dit da. Da, di da, dit da, da, di da. You can do that. And you can become quite proficient. I know in the 60 odd years I've been doing this, I can comfortably transmit and receive at around 35 words a minute, which is fairly good. Now compare that to typing speed. That's not much, but it's okay. Now, if you have a microphone or some other complex way of putting information in, you can mix the modulation, the information with the unmodulated signal and come out with an AM signal like this. All right, do I have everybody still understanding what we're talking about? Now, what's happening now is that we have two signals combined. The carrier signal, which is on a certain frequency, like say 50.005 megahertz. It's not doing anything, but if you can make the strength of that signal go up and down according to your speech patterns, or if you're a broadcaster according to the music patterns, then you're sending information, which when it hits the antenna again, it'll turn into a radio wave. All right, here's something very, very old-fashioned. Let me see if I can. All right, good. All right, back in 1906, a gentleman in Massachusetts surprised a whole bunch of shipboard operators because they were just used to hearing Morse code signals. He had an alternator to generate the radio frequency signal. And just like the alternators in our car, except it's whirled at quite a high frequency. Something like 100 kilohertz. All right, these are old symbols, old schematic symbols for coils, actually. So he had the generator generating the electrons flowing, and it generated a signal once it hit the antenna. He hooked up a microphone, wound it around the coil, and modulated the signal. So you have the audio signal and you have the radio frequency signal combined. And this is the microphone that he used. You can see these little, well, what do they call them? Spigots. You'd put hoses in there and circulate water because it would get very, very hot being associated with the high-powered RF signal. And what he did, he played a violin, read some poetry, read from the Bible, and I think he also played the phonograph into it, and gave a very, very nice Christmas Eve demonstration of what could be possible. It wasn't until the 1920s, early 1920s, that a commercial radio station, I think it was KDKA in, was it Pittsburgh? Actually did the first radio broadcast to people. Okay, so there's the alternator, there's the microphone. Alternator is doing this with furnishing a carrier. Microphone's modulating it, and it is making a combined signal. Now, how do you break it down? This was the easiest way. It's called a crystal. And what it would do, it's a semiconductor. And what it would do, it would get rid of the carrier and just show the increase and decrease of the modulating signal. And that could go into the headphones, which went right here. You could use different kinds of material for crystals. I know during the war, people would use a rusty razor blade. The rust would actually act as a semiconductor. Another guy used an acid as his detector, and it acted like a diode as well. Of course, that's kind of tough to carry in your pocket. All right, talking a little more about the combination of the carrier and the modulating signals. You saw before, let's see if I can get it back. Yeah. Okay, you saw this. The voice signal is duplicated, positive and negative. So what you have it's called sidebands. You have negative sideband and a positive sideband. They both have the same information. Now, this is a broadcast frequency, AM broadcast frequency, 800 kilohertz, which is what, CKLW in Windsor and Detroit area. And from 797 to 803, that's 6 kilohertz wide. So it takes a chunk of spectrum, but the information that you need is only on one side, which is about 3 kilohertz, 2.7 according to this. So this is waste. And this is taking up power, which if you could put it in here, would make your signal go a little farther. By using filters remember we were talking about resonance circuits and how they could either let a signal pass or suppress a signal. You can use filters to suppress the carrier and to suppress one of the sidebands. So you have a single sideband where you can concentrate all the power of the radio into it. So it makes it a lot more efficient and gets it out farther. Now we have an upper sideband and a lower sideband. And your radios will select, or you have the option to select which sideband you're going to use for your communications. There is a convention that has been used since I guess after World War II, that if you're operating on frequencies that are above 7 megahertz, you will use upper sideband, and above the 7 megahertz band. So 7 megahertz would use the lower sideband, 3.5 and 1.8 and such would use the lower sideband. And all the others would be upper sideband. And of course, the government chimed in, and all government and airlines and such will use upper sideband no matter what. Okay. Any questions so far? All right. I'm going to go a little farther. There's another way of modulating a carrier wave. And this is something that you're going to probably be more intimate with as a technician than what I just described. You have a carrier wave and you have the modulating voice music signal. And instead of making the amplitude, making the volume go up and down, you actually wibble wobble the frequency of the carrier. So you can see here, here's a peak, there's the peak. There's a null, there's the null. So this uses different circuitry. You use something called a discriminator circuit, which will translate this wibble wobble into something that you can put into your loudspeaker. Now, there are good things and bad things about it. Amplitude modulated signals will go farther and are more intelligible over a long distance. Generally, you'll use FM in the high frequencies that you're licensed for. 50 megahertz and up. There's a little bit of FM work done on 10 meters, and that's only about 100 kilohertz of the whole band. It's broader, so you're not, but the VHF, UHF bands are much bigger, and you can accommodate a wider signal, a signal that takes up more spectrum. One of the good things about FM is that it sort of ignores static sparks, things of that sort. That's actually amplitude modulation. One other thing that is kind of confusing is that if you have two FM signals that are interfering with each other, the discriminator will pick one. It'll pick the strongest one and ignore the weaker one. So that's a good thing and a bad thing. Because if you in a single sideband, if you have a weak signal, a good operator can kind of pick out the weaker signal out of the two interfering voices. Okay, any questions so far? All right. I'm going to stop here and go from a little bit. Okay. Any questions? Everybody confused enough? All right.
Yeah, we'll go with that.
Okay. Now, all right, let's I haven't gotten into, well, I'm going to get into a slightly more complicated type of signal transmission. And maybe that'll segue into um, TV and other kinds of stuff going on, because there is an awful lot of stuff that we do that we can do if we're interested in it. There's TV, both fast scan and slow scan, the signals we can send. There's a fast scan TV is only on the, I think it's what, 220 on up, something like that, 220 megahertz on up. There's slow scan TV. Even on 20 meters, people are sending TVs or pictures to each other using special software. There's this other stuff that is just being touched on in our manuals right now. I'm sure that the next manual will have a lot more. We had these digital signals like the PSK, which they'll talk about in the manual, and they were talking about FT8, which is actually what 2018, 2019 or thereabouts that Joe Taylor came out with that, which is just terrific because the computer does most of the work, and you can pick up signals that your own ears cannot discern. And I don't know. I used to think that all these digital modes were for us old guys because our hearing is going. So let the computer do the work.
Hey, Jerry, can I interject something real quick
Sure,
here?
go ahead.
It's a good segue into, and this is not test worthy. This is just for you guys when you get your license and you get out there and you start doing stuff. There are hams that feel that certain things are amateur radio and certain things are not amateur radio, and they'll be happy to tell you. And I've heard people say, oh, FT8, oh, that's malarkey, that's not amateur radio. Um, here's the thing that I want you to take away. You are getting a license. And if it requires that license, then it's amateur radio. So don't let anybody tell you how to do your hobby. If that's what you like doing, don't let anybody get in your way, because there are lots of people that will say negative things about different. They think if you're either rag chewing, which is just talking on the radio, or doing Morse code, if you're doing anything other than those two things, you're not doing amateur radio, and it's garbage. So don't let anybody tell you that. If somebody does, just ignore them. That's it. That's my little soapbox, Jerry. Thanks.
Amen. Okay, let's see if I can get this thing to work again. Come on. I'm screen sharing. Okay, why is it not going? All right. Okay, I'm gonna try again. Okay, hang on. Oh, chapter 5 again. Okay, back to screen share. Okay. Okay. Now here's I'm not okay. Here's another type of signal. It's a fairly ancient form. I don't know if you any of you remember what a teletype machine was. These were remotely operated typewriters, and they used a 5-character code called a Baudot code, and it would be sent through the radio as tones. You'd have dee 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 dee. Let's see if I have a no. Oh, geez. Okay. It crashed. Okay, sorry about that. All right, let me start it up again. Chapter 5. All right, I'll have to go through that a little later on. Let's get something else going instead. Oh, okay, here it is. Okay, that is a teletype signal, and if you have an HF radio, you can sometimes hear that. It's mostly obsolete, but most of the current radios have a provision for transmitting it. I have this IC 7300, which was brand new and revolutionary back in 2016, and it actually within the circuitry it has a way of transmitting it and a way of receiving it, so I can actually see signals on the screen as they transmit. And there are contests, quite a few during the year, where people will get on and send this. So it's good. It's fairly accurate, but of course it's not as sensitive as some of the other things that we have. Okay. All right. Okay. And by the way, to remind you, here are your privileges as a technician radio licensee. And on the high frequency bands, HF, you have 1, 2, 3 bands, 80, 40, and 15, where you can send Morse code only. Now, that's made easier nowadays because we've got gear that will both transmit and little keyboards and little gizmos that will pick up the Morse code and translate it into lettering. I think you can buy one of those things for about $100, or probably find some cheap Chinese thing to do that. So for those of you who want to learn CW, to learn Morse code, this is a good opportunity. And actually, these bands, 80 meters is usually good only during the night, or from sundown to sunrise or thereabouts. Not too much distance to it, although sometimes early morning you can hop the pond and talk to people in Europe. 40 meters is good during the day for up to about 1,000 miles. And at night, I have talked to a Japanese station on it. 15 meters is usually dead during the evenings, but during the day it's worldwide and quite exciting. 10 meters is spotty. At night it closes down and don't get out very far. Although there's certain phenomena like the tropospheric scattering, which does sometimes dip down to 10 meters. But as a technician, you have a lot of good privileges. Let's see, will this do that for me? Come on. Okay. Everyone see the enlargement there?
Yes.
Okay. Right. First of all, you have 200 kilohertz of privileges using single sideband voice and CW. Down here, you can use teletype, as you just heard, and the data, the FT8 type of signal, which I talked about a little bit. And this, on good days, it goes worldwide. It's really wonderful. 6 meters, what do they call that? The golden band? When it's open, it's wonderful. And you can use, you have full privileges, full power. Now down here, you're limited to 200 watts. Up here, you can use 1,500 watts PEP. And of course, up here, you get some tropospheric scatter up here too, as well. Then, of course, when you get up to these points, you can start talking to moon bouncing, talking to the International Space Station, communicating through satellites. And let's see, I think no, above here, yeah, above here in the 2450 or thereabouts, I think the International Space Station has a TV channel that you can, or TV allotments that you can get into as well. So you can do an awful lot of good stuff there. All right. Okay, any questions so far? Now, your manual has a full chart of these. It's a little more complicated because it has all the different classes and all that. But this is what you can do. Okay. Now, talk a little bit about equipment. And of course, the big thing there, I'll get back to FT8 and things of that sort. All right, the big thing here is how much money you got, kid. Because there are all sorts of different things that you can do. I'll show you some pictures of various types of equipment and some of the controls. It used to be that the radios came with all sorts of little buttons and knobs and stuff. And now there are fewer buttons and knobs and more menus. Okay. Wait, let's go to let's go to okay. One of these guys. All right, this is a typical transceiver for UHF and VHF. This is a dual bander, and actually it's a blessing and a curse because it only has two bands, which means you're going to be neglecting the 1.25 meter. That's the 220 megahertz band, and we've had a bad example of not using certain bands and losing them, just like the 11 meter bands, which we used to have, was taken over and given to the citizens banders because simply it wasn't used. All right, so this is typical of a fairly good quality transceiver. You can see that the faceplate is detachable. And you can actually mount it on your dashboard. There are various mounts that will either clip to a heating vent or whatever you have. And you can use that. You can put the rest of the radio under your seat or by the back of the car, especially if you have an antenna to hook up in the back of the car. And there's a wire that will go from here to there. One of the things that's getting concerning about using something like this for mobile operating, these are usually running around 25 to 50 watts, and we'll get into why that's preferable to having a handy talkie at your hip. One of the things is that we're getting more and more hands-free laws being passed in the United States and Canada, which means using the microphone. I think a lot of states still have an exception for ham radio operators, to be able to use a microphone, and police officers and so on and so forth. But if you're using a CB or something like that, family radio service, something of that sort, then it's illegal. Okay. Now, so you have two bands that you can operate on. Each has its own virtues. Most of the activities are actually on the 2 meter band, 146, well, 144 point something to 148. And it's FM, which uses the wibble wobble type of putting your voice information on. You have two dials, one for each of the bands. And when you start hitting some of these buttons, or even the buttons here, and you can access the various menus. There are an awful lot of settings. Sometimes it gets a little too complicated, and you can use software to get into the memories of these radios, and you can set up all the parameters, the frequency, the transmit and receive frequencies, the CTCSS or PL frequency that encodes the different information that a certain repeater will use. Again, there's lots of stuff I can talk about on this. These have memories. Looks like it's 999 memories in each one. I don't think anyone's going to be that busy. But I remember that I put into memory an entire trip from here to Madison, Wisconsin, with as many repeaters as I thought would be useful, all along the interstates and through Chicago and up to Wisconsin, and it worked pretty well. There's a service called Repeater Book, which actually has software that can make a listing like that you can put into memory. Okay. All right, you have volume controls, and you see this SQL, squelch. You can hear background noise, and what the squelch does is cancel out the background noise to a certain level, so the radio will only hit the loudspeaker if there's a signal. And this is variable. This is nice because it has a manual squelch. Sometimes you have to set it by the menu board. Some of these will, if you hit a button, will give you the weather channel so you can get a weather report. Some of them will even have a broadband repeater or a receiver, which you can sometimes listen to FM. I don't know why anyone would, but anyway, you could listen to FM. You can hit some of the public service frequencies, like the railroads and things of that sort. Used to be you could hear police frequencies. I remember listening to one police officer huffing and puffing as he was chasing a perp and holding onto his handy-talkie. But they're going into different type of channels, different types of, I guess it's called trunked channels, and they're sometimes encoded. Okay, any questions on this so far? But it's fairly complex, and you can do an awful lot with it. And it's a learning curve. You're going to have to either read the the manual, Heaven Forfend, or go on YouTube and find a tutorial on these. Okay. So far, I've been talking about what's called analog. I'm not going into the signal processing, aside from what I talked to you about the teletype on it. And for 99% of the time, it's great. It works for just about all repeaters. But there are some repeaters that are getting digital only. There's some radio clubs that are doing digital only, and doing digital is a fairly efficient way of doing it if you have the computing power. And since most of these radios are majority computer, most of them can process it. I do have a bit of an objection, as Mike was stating. There are certain things that I'm an old emergency management type of person, or civil defense, I guess they'd call it. And when you start getting into some of the systems like DMR, where you actually use the internet for part of your communications circuit, I have to stop, because if something happens and the internet is down, where are you? You're back to analog. And that's all I can say. But there are a couple of others. Let's see if I can find anything. Oh,
4x1 what?
okay.
4x.
Okay. Before we get into other stuff, here, this is one of the popular radio antennas for VHF UHF. This one does two bands. It's I think about 4 feet long, 4'2", and it's designed to hang on your roof someplace, either on a tripod, or you can still go to Home Depot and pick up a mounting kit that will strap around your chimney if you still have a brick chimney, and that will support an antenna like this. It will radiate pretty well into a repeater, or give you a fairly good range. The higher you are, of course, the better transmission reception you'll get. And there are some people who are going to use this for direct communications with people up to 20, 30 miles away. Beyond that, you're going to use repeaters, you're going to use other systems of communication. If you're going to do satellite work, or even moonbounce, you're going to look for a Yagi type antenna like this. These two are put in tandem and radiate a tighter beam, better use of your power. And it uses a special rotator that does the azimuth, that goes around on a horizontal basis. And as you see, it does elevation. You've probably seen those science fiction movies where they're tracking satellites and things using antennas like this, which are rotating around and tracking the satellite as it goes. Okay. Let's see. All right, I close the screen sharing window. Okay, any questions so far? No. Okay. Well, you guys are either very gifted, very good at picking up all this information, or you're going to be scratching your head later. And I keep volunteering. No, W9NPI@ARRL.net, and I'll answer any questions you got. So, no, please don't be shy. All right. Let's see.
Four X with his I've response bar a +3.
All right. I'm going to try to find repeaters now. Okay, I'm going to share again. All right. Have we discussed repeaters very much with you?
I
No.
don't think on here, but I'm definitely rather versed in it based upon my GMRS aspect.
Okay.
Yeah, Jerry, I don't think we've covered repeaters very much, so maybe some of the people may not know what you're talking about.
Okay. All right. Well, when I was younger, the handy-talkie was a big thing. It was a chick magnet. Here I'm hip. I'm different. Look at this. And they look nice. They look very, very nice, but they have a very, very limited range. Um, let's let's see if I've got. No, it's not there. Okay, very limited range, maybe about a mile and a half from one handy-talkie to another handy-talkie. A repeater is an automatic station which operates on two frequencies. The repeater receives your signal from a handy-talkie or from a mobile radio station, and then rebroadcasts it on another frequency. Usually on 2 meters, there's a 600 kilohertz separation between the transmit and receive frequencies. And on 70 centimeters, 440, there's a 5 megahertz separation. And the radios are usually preset to use that kind of separation. Yeah. Now, how many repeaters are there? There are repeater directories, and this is from one site. I have an email that I send all of you after the class. It's called Whatever Young Ham Should Know. And it will have some websites which will show the different kinds of repeaters. For instance, this is a map of all the repeaters in Michigan. As you can see, there's quite a few of them. And some of them have very long range, others have fairly short. Like our own club repeater has ostensibly a 30-mile range, which means that If you have a handy talkie, I don't know if you 30 miles out, you'd be able to get the repeater very easily. But for instance, my handy talkie, which has it runs 5 watts, has a range of about a mile and a half from my QTH. I can hit the club repeater, which is about a mile away from here, and it will rebroadcast my signal over a 30-mile range and also pick up signals from that range. There are even longer range repeaters. I remember I was doing some volunteer work. I was delivering blood with the Red Cross, and I put my mobile radio into the truck. And as I was driving downtown to pick up my shipment, I had a conversation with 2 guys, one in Mount Clemens and one in Monroe, using the same repeater. So it extended my range quite a bit. Okay. Now, this particular repeater directory, if you click on one of these repeaters, it will tell you, and it happens to be the Hazel Park Club repeater, which is located in Oak Park at Greenfield and 10 Mile. 146.64 is what you'd set your radio to receive. And it has the call sign W8HP. By law, the repeaters have to identify themselves, and if you know enough Morse code, you can pick up what the call letters are. And notes it says 100, which is the subaudible tone, or PL tone, or CTCSS tone, which we'll get into in a minute. Okay.
Jerry,
Yes.
my screen, it's either stuck because I have your file manager up on my screen and it has 8 different files, but I don't see a directory of any kind.
Same goes for me.
Well, let's stop that and start again. That any better?
Now I
Much
see
better.
the map.
Thank you.
Yes, that's the map.
Okay. So this is the immediate area. Okay, so let's see, okay. I guess it's probably this one, which is the Oak Park one. I don't know. I think this information is obsolete because I don't think we have a 1¼ meter repeater anymore. We do have one that in Beverly Hills on the 440 band, which we sometimes use as well. Okay. We'll talk about the PL or CTCSS. The repeater, most repeaters will not respond unless you have the secret handshake, the secret code. 100 is the secret code for this one. What this is a 100 hertz tone that your radio generates. For the last 30, 40 years, the FM, the handy talkies and FM equipment have had that capability, and you can set it for each of the repeaters that you use. When it hears that 100 hertz subaudible tone, it will open up. It will receive your transmission and rebroadcast it. A lot of people make the mistake when they set up their Baofengs, they forget that they have to set up the tone. and they start complaining, why can't I get out? That's the reason why. And it's there for a good reason too. I think, 60, 70 miles away from here in Canada, there is another repeater that uses the same set of frequencies. And if propagation is right, tropospheric or otherwise, sometimes a mobile over there could trigger our repeater, or one of our signals could trigger theirs. So if they have a different subaudible tone, then no, it's not discrimination against people. It's just a way of minimizing interference. So that's the secret of the PL tone, and you can go to artsci.pub or various other types of places, or this place, and get the tones you need. So it's a matter of public record. We're, according to our license terms, we're not allowed to encrypt things. Okay. Anything else on that? All right, I'll go
So-
into yeah.
Quick
Go ahead.
fast.
Oh, was
Someone
that-
had bit before me.
So, tell me how the tone relates to our engagement in terms of, does it establish a baseline? Is that what it's doing as far as the repeaters? I live in downtown Detroit, and there's a repeater, I understand, on the Renaissance Center. So,
yes.
so how does that interact with us when we start to engage in talk?
You have to look up the tone that particular repeater uses. Usually, most of the repeaters in a certain area will use the same tone. So
Think of it as a key. It's the key to get into the repeater.
right. So if you set up your Baofeng to the Renaissance Center's repeater, you'll set up that particular tone, and it's probably 100. So as I
Gotcha.
said, it's not a discriminating type of thing. It's just to eliminate certain kinds of interference. Now, one of the other things that a lot of these Chinese handy-talkies have, and sometimes people will inadvertently set those, they have a tone for the receive. Now that's a bad thing, because if you set the receive tone, your radio will not respond unless it hears a signal with that 100 tone. And nobody's sending that. So I've heard other people complain, I can't hear anything, and that's why. So you leave that open. Don't set a tone for the receive. Just set it for the transmit.
So, with a piggyback off of that, does Ham have the capability, or do they just generally do the transmit only, or is it the CTCSS tones where it's transmit and receive that ham radios will do it? Followed by the question, do you guys also utilize DSS tones?
DSS or DCS?
DSS, I believe. It might be DCS.
I think
Because
that's
again, mind you, I'm like a year and a half into GMRS, so I've learned a little bit more about receiving, transmitting tones, setting the CTCSS on my DB20G, and then I've got some new handheld radios, and they have a quote unquote encryption, but it's not encryption because it's illegal to do. But it's I can program a 5 alpha numerical code combo between 1 and 250, and unless if the receiving and transmitting radios both have that very specific code, it's open broadcast net. Anyone that's on the channels can hear us, but we will never hear anyone else unless you have that very specific 5-digit alphanumeric because it's a combo. But I was curious with ham if it's similar or not.
With ham radio, it's there's no point in encoding the receives.
Okay.
Well, no, if you have a company, you just say you're running a plumbing company, you don't have to listen to every Dick and Willie talking on the radio. You just want to hear your dispatcher. You just want to hear your company business. But no, as hams, we're supposedly open to anyone, unless you want a very, very exclusive group. If you want exclusive groups, we can get into, we'll get into DMR and things of that sort in a minute. And that's a different type of thing. All right, so I've been talking about analog. We have another system, well, several different systems that's some are kind of company bred. If you have an ICOM, you would have the D-Star capabilities if you want to pay a little extra for it, and it just means that it's encrypted in their way, not encrypted, but it's a way that only D-Star's radios can talk to other D-Star radios. And that's fine if you're running something like emergency management where everybody has the same kind of radio. I know that when I was in the Amateur Radio Public Service Corps, I was in charge of a network that linked the emergency rooms of 17 hospitals in Oakland County. Each hospital had a radio in the emergency room or in their emergency operations center. And since you're running a closed network, so to speak, you're just communicating with the emergency operations center in Pontiac, then it would make sense that you would not want to listen to somebody else. But it gets to a point where we don't have things that well standardized yet. So, and again, in my Whatever Young Ham Should Know, I talk about how, let's sell everyone a radio. They can only use our radios to communicate because the other guys with the other radios can't hear us. It's almost like Gillette selling their cartridge razor blades so no one else can sell razor blades to these guys, or the camera companies had those little cartridge cameras. You could only use our cartridge, that type of thing. And it's a good sales tool, but it's not really good for the general public. Okay. Now let's digitize just a little bit. We can set a little timer. We can take a radio signal.
Hey, Jerry,
Yeah.
just checking real quick. My whole thing froze up and I had to leave and come back. But I think, and I'm not sure whose screen was froze up. I just want to make sure you're not froze up here. I'm still seeing the map with the repeaters.
Yeah. I'm
Okay.
still there.
Just I wasn't sure if you had changed or not.
Okay. Okay. Well, so far everything's working. Okay, so again, I'm going to go an inch deep and a mile wide, but you can slice the time intervals of a radio signal. You can do very, very fine slicing every various microseconds of time, and you can share a single channel if you have your clocks all set up. I can talk to somebody, and someone else can also talk on the same frequency, but we're using different time intervals. And that's pretty much what DMR does. And you have different DMR groups, and what you're doing is actually telling the computers how to synchronize your signal. For instance, a very poor example, a state police car that's in the Upper Peninsula has to transport a prisoner down to Detroit. Its radio is synchronized to talk to people in Escanaba. They get down to Detroit, and the only people they can talk to are in Escanaba. So doesn't make too much sense. Again, my own prejudices. It's not that practical, but it works. You can you just have to get things calibrated or set up with the right talk groups. And it's another example of you're going to have to somehow or other make a transition into the internet to get things going. Which, yeah. All right. And any questions on that? Okay. I don't think I have. Do I? All right, I'm going to do just a little bit of a refresher on this. Get back to the HF radios. Can everybody see this Flex radio on the screen?
Yes.
Yes,
Yes.
Okay.
they're kind of expensive, aren't they?
Well, how much money you got, kid? Is pretty much the thing. Yeah, they're in the $5,000, $6,000, $7,000 range, and you can accessorize it. But it's a box. It plugs into your computer, and it has just about every function you can think of. It's going to transmit on CW. It'll transmit sideband. It'll transmit AM and FM signals. You have to make sure that you're in the right frequency allocations for that. You're going to find that because of the circuitry, FM and AM will consume a lot more power and dissipate a lot more heat because the circuitry is not as efficient. So if you're going to run 100 watts CW or 100 watts sideband, you're going to be running something like 25 watts AM or FM. Otherwise, you're going to start overloading the radio. Now, the radio will protect itself in most ways. It has what's called a fold-back circuit in the amplifiers, and if there's too much much power being expended, or if the SWR, Bob, did you talk about Yeah, you talked about SWR a little bit. If the SWR is too high, it will fold back and reduce the power. Might even reduce the power down to 3 watts if the reflected power is too much. So there's a little protection there. But again, you can take your Chevy Equinox, or you can take your Maserati to the grocery store to buy milk. What's the point? All right. Here's a Flex Radio with a screen, which is very, very nice. You can see that these screens are very interesting nowadays. We didn't have that stuff a few years ago. And what it does, it's a panoramic readout of the entire band, or as much of the band as you want. It will scan and see who's talking above you, who's talking below you. Okay, right over here, you have an awful lot of activity going on. It could be a contest. I know that on the HF bands, there are they call them sprints, where for 1 hour everybody gets on and they get into a mini contest and contact as many people as possible. Or this could be a one of the frequencies that we have the FT8 going on, but that takes special software to open up. All right, here's one of the two very popular transceivers. This does 160 meters, 1.8 megahertz, all the way up to 50 megahertz. Wait, the 991, Bob, that does 2 meters 440, doesn't it?
I
Yes,
don't
the
think so. I think it
991
goes down to
does.
6, doesn't it?
Yeah, it does. HF plus 2 meters and 440.
Nice.
So this is a very nice rig in the box. Although, as a matter of taste, most hams will buy a separate 2 meter 440 radio. Because, if something goes wrong with this, then you're stranded. But anyway, here's something that will tell you what's going on. It's mostly a menu type of radio, and it's got all sorts of things. If you're working on say CW, and there's either a tone or someone's tuning up right next to you, you can push a button or turn a knob and actually filter out the interfering signal, or narrow it so you can just hear one or two guys instead of a whole bunch. So it's very, very nice. This has actually two radios in it, two receivers, because it's the practice, especially with distance stations, that they will transmit at one frequency and they will ask you to respond at another frequency. In this case, he's transmitting on 14.195 and said up 5, transmit to me up 5 kilohertz. That way you don't have a whole bunch of people trampling on his signal. And what he does at his leisure, he looks here and he sees a station he wants to contact, and he'll tell him. Sometimes it gets pretty industrialized. The guy will say, "Okay, all right, this is 9U1UA. I hear FS7RT 59," and then the FS7RTs will say, "Yeah, 59, thank you." And that's the conversation. That's the QSO. So it gets pretty industrialized like that. So I'm an old-fashioned guy, and I like to chat sometimes. So sometimes you try. All right. Different kinds of adjustments. Usually these things have a couple 100-page manual, and there are tons and tons of YouTube documentaries on each of these things. For instance, no, the A to B, the A equals B would set both of these frequencies at the same frequencies. In this case, this is the primary, so this is the secondary. So if you put A equals B, this would go to 14.195. A/B would switch between this and this, would make that the primary and that the secondary, and so on and so forth. Clarifier is something that would move your receive frequency up or down from the transmit frequency in case there's some interference or something of that sort. Split is the function that would give you this split between the transmit and receive. So you can talk to distant stations like that. V/M, A was M, those are memory channel functions. RF gain makes the receiver more sensitive from the antenna down. AF gain does the audio amplifier, the loudspeakers. A multi function type thing, you'd hit on certain things like filtering out interference. You hit that and then you use the multi knob to move it up and down. Otherwise, in most radios, the multiband will change the frequency of the variable frequency oscillator, the readout frequency up or down, thereabouts. Changing bands, changing the mode. It's different things. And again, if you're going to change the mode from anything from CW or sidebands to anything else, you should consider reducing the power. All right, this is my favorite, which is almost equivalent. It's IC 7300. It's a little more limited because it only goes up to 6 meters. It doesn't have 2 meters 440 on it. But to me, it does everything I wanted to do. Of course, the knobs are different. The learning curve is going to be a bit different. I don't know, Bob, does your 991 have a tuner?
It does. It has a tuner, and you can shut it off if you want to use an external tuner, but it does have a tuner.
Okay, yeah, because both of these radios have an antenna tuner, and as you've found out, the antenna tuner is a misnomer. It just makes your transmitter happy, and it's very limited. This will correct up to I think an SWR of 3-to-1, which is not going to get you very far if you have some of these currently fashionable radio antennas like the NFED halfway. For that, you need a more sophisticated tuner, like an LDG Z100 or something of that sort, which will set you back about $200, and will give you a correct an SWR of I don't know, about 20 or 30-to-1 thereabouts, and it's worth it. Okay. Here's this has two different function displays. This one tells you what's up and down the band. And actually with this one, I know it's got a touch screen. So actually, if I touch this with my finger, the radio will shift frequency to where I touched it. And this actually analyzes the radio signal that you're receiving. And this is a guy talking, and this is his speech pattern pretty much. So I mean, there's all sorts of stuff in here, but that pretty much what it does. This does have a squelch function, so you don't use that very much on HF. Usually on about 10 meters, it sometimes limits the amount of static you get. So that's pretty much what that does. All right, any questions on it?
No, sir.
All right, and okay, the 991 is going for what, around $1,200 now. The 7300, they just came out with a 7300 Mark II, which will probably go 16 or $1,800. So the old ones will I think I've seen them on sale for about $800 or $900. Wonderful buy. It's a good buy. Oh, one other thing I didn't mention. This has a function which turns me into a robot. I can touch a button and I can either send code or talk. It will record my voice. And if I'm in a pile up waiting to talk to this foreign station and I'm getting hoarse with yelling my call letters over and over and over, I can just touch a button and it'll say W9NPI, W9NPI, as much as I want to touch the button. And when the guy says, and you're 5'9", I can touch a button, you're 5'9" too. So that's my conversation. I mean, yeah, robot versus robot. So, yeah, again, I'm old fashioned. Okay.
Jerry, how many questions on the exam might address all these different features and their associated principles on the test?
Okay, go to the what is it? Chapter 10, the exam question pool. And let's see. Bob, I think you were touching on that in your intro, where they have that little list of who's
Yeah, but I
how many
think
questions for
her
each.
actual question was asking about how many questions are going to deal with the buttons and knobs, and none. They'll and they're going to ask you about oh
They'll ask you about
general
squelch.
station equipment stuff and
What's a repeater?
They
yeah,
will
and
ask you
Things like
about the
that.
squelch.
yeah,
I,
but
I don't
as
know.
for the buttons, they're not going to ask you any of those questions. But that was interesting stuff, and it gives you an idea about what's on, modern equipment. So I hate to say it, but one of the buttons he describes is on my 991A, and I didn't know what it was. So
Cool.
Okay, let's see what else I've got left on there.
anyhow, questions about station equipment in total are only about there's only four of those questions that are going to appear on the test, but they're not going to be about buttons or knobs.
No, I'd be more concerned about uh, what does this is a circuit. What does this part A or part 3 do? That kind of thing. All right, one. Uh, Come on, come on. Okay. Okay. Um, Everybody see this TYT?
Yes.
Yes.
Okay. One of the sources that I trust, it's called R&L Electronics. They're out of the Cincinnati area. And they sell various types of equipment. The prime stuff are from Japanese manufacturers. You know, the ICOM, Kenwoods, and Yaesus. TYT is sort of a secondary manufacturer, and they make stuff that's a bit cheaper. Maybe not the same quality, but not that bad. And the prices are fairly good. This is a fairly old ad. Sales are all over the place, I guess. And of course, you have a problem now. We don't know what the tariff structure is going to be. But they will have things like here's a combo of uh, this is a 4-band, 10 meters, 6 meters, 2 meters, and 440 plus a power supply. And at that time, a couple of years ago, it was $300, which is a fairly good buy. That plus maybe $100 for the antenna, and well, you got to buy cable and things of that sort, and then you're in business for VHF and UHF. The FM on 10 meters, I think, is not available to technicians, and that's a bummer. But you get 3 bands there. That's pretty good. I don't know. 6 meters, there's not a heck of a lot going on right now, unfortunately. But sometimes, if the bands are open, you can start talking to Europe. So, you never know what's going to come down the line. Okay. Well, let's see. Is there anyone else I haven't insulted? No. Okay. FT8. Let's talk a little bit about that since we have the time. All right, this is an older list when I first got onto FT8. And if you can take a look at the contacts that I made, just about everywhere. And since that time in September 24, when I first started FT8, I've talked to just about everybody from Siberia down to Antarctica, and using mostly this mode. It's called a weak signal detection system, and the computer does most of the work. I've made contacts with stations. I can see the signal on the software, but I can't hear it. But I'm making these contacts nonetheless. All right. I'm not sure you'll be able to hear it, but let me try anyway. I'm going to turn on my radio software, That's another thing that is really neat.
Now, if you're doing that through the internet in your computer, is that a software that's available to technician or is that for the advanced?
This is my own software. I bought it fair and square. This is called Ham Radio Deluxe, and it'll set you back about $100. You can download it. They just made a major modification on it, which is supposed to make it a lot better. It keeps a log for you. It also spots. In other words, if somebody makes a contact with a distant station, he'll broadcast it to everybody else. So other people will try to listen. All right, let's see if I can get this thing shared. Oh. Okay. Okay, this is the logbook function. These are the stations that I have contacted, mostly using FT8. I'm not sure how far back it. No, I have made some sideband and CW contacts, but no, depending on the different conditions and band conditions, at night I will use the lower frequencies like 60 meters, which is 5.3, or 80 meters. My antenna is not very efficient at 80 meters, but I keep talking to people, and I was making some nice conversations with a guy in New England and Canada, and some guy from Belgium popped in, that kind of thing. This is the spotting log. This is connected to the internet, and it will tell you what frequency, what station, and here is Chile, China, and these are on the 20-meter band and at different frequencies. And if you click, the software controls the radio. If you click on this, it changes the frequency of the radio to that station, so you can start talking to the guy. It also changes the mode from FT8 on this 14155. It's sideband. So it's a pretty neat thing. And let's go down and let's see if I can.
Hey, Jared,
Yeah.
do you ever have an issue getting into China or other communist countries? Are the rules different?
When we get into rules and regulations, we'll get quite a bit of that kind of stuff. We don't really have that many countries that don't want to talk to us, that we're not allowed to talk to. There are certain ones, like North Korea is one of them, Yemen, another one, that kind of thing, where you're not supposed to talk to these guys. They're not supposed to talk to you. As a matter of fact, one of the questions I put up, and you'll probably remember it, but my brother-in-law is over in North Korea. He's selling the government some timers that they're going to use in their missiles, and he needs the latest pricing. He's willing to pay me $500 if I get the information and send it to this North Korean station. And my question is, how many rules and regulations am I violating doing that?
A lot.
a lot. So that's pretty much it.
Okay.
Okay, now here's right, here's a
Hey, Jerry, could I just hit on that for just a sec?
sure.
Because it might help, Kim's mind a little bit to where she might have been thinking or not. Every country has their own band plan. We have our band plan. Jerry showed it to you earlier. It's that color coded chart that says you're allowed to speak here as a technician. You're allowed to do Morse code here as a technician. Oh, but you're an extra or you're a general. You can do more. You can go here and there. Every country has their own band plan. That band plan says I can transmit on those frequencies. So if I reach out to someone in another country and I stay within my band plan, everything is okay. 9 times out of 10. Like Jerry said, there's only a couple of countries you can't. But oh man, if someone doesn't say, "Hey, I'm from North Korea," I don't look at the call sign and look up the first 2 characters and see what country that is and, blah, 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 blah. You can figure out who's talking somewhat easy by the call sign, but a lot of people don't till that conversation's already going and I've written you in my log. And so you may talk to someone you're not allowed to or not supposed to. But if you find out that you are, then you stop.
Yeah, just don't talk.
But
Yeah, Mike,
you can pretty much
there is
talk to any
essentially,
communist country. You said any communist country. Most of them, except for I think North Korea is the only communist country that we aren't allowed to talk to right now.
there is a question, Mike. I've picked a guy up on FT8, and he's in a little enclave. I think it's between the Ukraine and Moldova or something of that sort. It's a little region that I guess they broke out for independence or something of that sort, and the only country that recognizes it officially is Russia. And they got their own call letters, and I made the mistake of talking to the guy, and then my software says, "Hey, this call is illegal." So I stopped.
Yeah, and it's good to also have, so because I don't have that software you said. I don't remember what it is now.
Hand Radio Deluxe.
Yeah, Ham Radio Deluxe. I pretty much use WSJTX with N1MM, and those are free. I like free, but Hammers does a lot more like that. And so that's good stuff to have and good stuff to know that it does do that for you too. So hopefully that helps, Kim.
Okay. Let's see, where was he? Okay.
Jerry, that country you were talking about, was that Transnistria
Yes, Transnistria.
that broke off from Moldova?
Yep.
Yeah, because they have lots of Russians there, and so they align with Russia. Transnistria. Yeah.
Okay. All right, I'm going to start sharing this one. Can I find? Okay. Can everybody see this?
Yes.
All right. This is an FT8 program, WSJTX. And I'm going to put it on the FT8 frequency, and let's see if it livens up. Okay, okay, it's got two screens. This controls my radio. And okay, here's my transmit and receive frequencies. And you can see these are the different signals. This is one voice channel. It's about 3 kilohertz, and you can put over 20 different stations on this thing. So talk about conservation of space. All right. These are the call letters of the stations that are on. This guy I have contacted before. This guy I have not. He's calling CQ, and I'm not planning on transmitting. But if I click on him down here, I have his call letters. We haven't talked about grid squares yet, but this is his location on Earth. It will tell me to point my antenna to 248 degrees, and he's 1,508 miles away. So, talk about washing dishes and waiting at table. This thing does almost everything. And you get the relative strength of the different signals. You can also see if somebody's interfering with you, so you can switch frequencies over. So this does quite a bit of good stuff. It also tells you the relative strength. When you get to -10, that's someone I could probably barely hear. It goes up to, I've seen a signal up to +32, and one down as low as about -23. So this is the current darling of the of signal processing. And I will tell you that I've contacted countries that I haven't contacted in almost 60 years of hamming. So it's good. Some people say it's not hamming, but heavens, in my history, I remember when there was a big war, single sidebanders. There's upstarts against guys who were using good old AM radio, and that was back in the 1950s and early 60s, and finally that settled. Yeah, reminds me of the old Paul Bunyan story, where Paul Bunyan's lumberjacks were plagued by mosquitoes. So Paul wrote down to Brazil, got a bunch of fighting bumblebees, and there's a big war between the two. They finally made peace and started intermarrying, and the result was that you had insects with stingers on both ends. So you never know what you're going to end up with. Okay, any questions on the FT8 at this point? About the only thing I haven't covered so far is, I'm going to get out of this now. The only thing I haven't covered so far is getting into, where's my brain burp? Okay, help me out. VoIP, voice over internet protocol, contacting the various repeaters.
Like Echolink and such?
Echolink, yeah, IRLP. Yeah,
Yeah.
that's a net-based, an internet-based way of communicating. And what that does, with my handy talkie or even online, if I'm registered with these services, and for registration, make sure that you have a copy, an official copy of your FCC license. Make sure you have a file on that so you can prove to Echolink and such that you are a licensed ham. You'll be able to access either using your handy talkie and punching your tones in. You can access repeaters all over the world. We had a fellow, unfortunately, he passed, was it last year? He was checking in from Thailand.
Yeah.
And I think Marcia Fleming's son checks in from Australia occasionally. So you can do an awful lot of stuff. Punch 2000, you're going to the repeater in London, England. Of course, my next door neighbor, I infected him with the ham bug, and he discovered the digital stuff, and he got into a channel. He speaks Spanish fluently, so he got into a channel that I guess a bunch of Panamanians were on. So he's buenos dias, and everyone's yelling, "Who are you? Why are you here?" So you never know the kind of reception. But most hams are friendly, and when we're talking about the communist stations or whatever, we try not to talk politics or religion, and we're trying to be international ambassadors. Wars will happen, wars will end, and hopefully we don't have too many bad feelings afterwards. But so I don't know how else to handle stuff like that without going crazy.
Yeah.
All right. Any other questions? Final questions? Closing up.
Good class, Jerry, and I learned some things about my own radio. All right, next week we're going to be covering Chapter 6, which is communicating by ham radio. Now, we've been starting to get some questions offline. Well, actually, at the member meeting about the FRN numbers, the federal registration numbers. Actually, we're going to be talking about that in the next couple of weeks. I think Mike. I think that's actually part of licensing. The
Yes, it
licensing
is.
chapter. Okay.
Yep.
Yeah. So we're getting there, and we will do that not next week, but the week after. So
And
Yeah,
hopefully,
and just so everybody knows, the FCC opened back up again yesterday. No, today, the 18th. They opened back up again today. I was on there this morning, and it actually works. So you will need your FRN to get your license. So since Bob brought it up, if you want to go out there and try to get it now, go for it. Well, you're not going to hurt anything. It's not too hard to get. But we will be covering that in a couple of weeks, though, on what you need and kind of a little bit on how to get it.
Question.
Yeah.
I've already registered for an FRN number with my GMRS license.
Same number.
Same number? Okay.
Yep.
It's with the FCC, so it's same number.
Yeah, just one number. That's all you need.
okay, and
For the
Even if you have
FRN
two
number, right?
personalities, you just need one number.
Yeah.
and one thing that it really bemused me a couple of years ago, a guy wanted to get he was ready for his license exam and all that sort of stuff. Then he went to the FCC website, and he said he saw that the FCC needed a social security number to assign the FRN. And he did not want the government to have his social security number. So he didn't get his license.
But
Go
the
figure.
government issues the.
Yeah. Hello.
Yeah,
Sounds like he doesn't pay his income taxes either.
Yeah, really.
Very well be. So
Aaron, were you trying to ask a question there? about the
I was
FRN?
gonna say with the FRN, your FRN is going to be different than your GMRS or ham call sign. Those are going to be two separated call signs if
Correct.
memory serves, just
Correct.
as
Your
a point
call
of
sign-
reference.
Right, your call sign will be completely different, but the FRN, the reason the FRN is there is because it's exposed. If it wasn't exposed, they'd be asking for your social security number. They use an FRN
Yep.
instead. So
I
that's
gotcha.
the purpose of the FRN.
And, remember, this stuff is public record. You can do a name search on the FCC records, and if you got it right, it will tell anyone who wants to know what your address is. So I advise a lot of people, if you really want privacy, use a post office box for your mailing address.
But if you do that, do not open a post office box and then ignore it. Because if the FCC tries to reach you by mail and you do not respond, they will take away your license.
Mhm.
So
Well, it's-
just be careful of that too.
Yeah, same thing with getting a good email address for them. Make
Correct.
sure that you keep that count.
Yep. And
Okay,
we'll
guys.
talk more about that in licensing too.
All right. Okay, I'm stopping recording. And